Hello everyone. We are discussing distance. And we know what are the properties of distance from the last class. Distance is something which has no direction. It only gives you magnitude. It gives you no directional sense. It's always positive because positive and negative, these things are associated with direction. We'll see it in today's class itself. The most important thing, distance is something which never ever decreases. If an object is moving, let's say this is the starting point. If object is moving, then distance will increase. If it stops, distance also stops increasing. If it comes back, then distance is not decreasing, still is increasing. Distance is basically what? Path length. And then we drew some graphs, and on the basis of those graphs, we investigated how distance and time things are plotted. I will plot several distance versus time graphs in a single graph, and then you have to tell me which part or parts are correct. So this is distance and this is time. Small d for distance, t for time. Instead of drawing separate graphs, if I draw all these graphs in this form, that graph starts like this, then it goes like this, let's say these are several graphs in continuation, and let's call them A, B, C, D, E, F, G. Then you need to write in the comment box which portions of this graph are correct. If you think that B and D are correct, then you will write B, D. If you think B, D, F are correct, then you will write B, D, F. Put down the question and write down your answer in the comment box. Which portions of the graph are correct? Look here. Look at this first part A. There are two things which are wrong with this part. If you are in the fourth quadrant, first, second, third, fourth, in this quadrant, D is negative, distance is negative graph wise, and also time is negative. Both things are not possible. D negative, T negative. And therefore, portion A of the graph is not correct. Because of distance and time both being negative. Now, look at this portion B. This portion B, your time is positive, you're on this side. But distance is still negative. As long as you are below the horizontal axis, your distance is negative. You're on this side, on the right side of the vertical axis, and therefore your time is what? Positive. But distance can never be negative, and therefore, because of this, your option B is not correct. This part is not possible. Regarding C, well, everything is correct with C. Time is positive in this part. Distance is also positive, and distance is increasing. In C part, there is nothing which is wrong, and therefore C is entirely correct. Time is positive, distance is positive, and distance is also increasing. Similarly, this part, time is positive, distance is positive, and it's not decreasing. And if it is not decreasing, then it is correct. Now look at this part E. In this part E, your time is positive, distance is also positive. As long as you are above the horizontal axis, your distance is what? Positive. But distance, you can see, is decreasing. Something which is not possible. And because of this, portion E is also not valid. Then F. In F, again, things are correct. Everything is positive and they are also increasing. F is also correct. The last part, G. In the last part, G, distance is positive. You are above the horizontal axis. Time is positive. You can see that distance is also increasing. You're going up. But still, this part, G, is not correct. If you know why it's not correct, then write down the reason behind G being not correct in the comment box. What makes you think that although in this portion of the graph, distance is positive, time is positive, distance is also increasing, but still this part is not valid? Why? Good, that is the answer. If you look at part G, in part G, what is happening? You're coming back. Coming back means if at this position, let's say time is 5 seconds, then at this position time will be less than 5. This is 5, this is less than 5. Well, there is no way you can decrease the time. In this portion G, time is decreasing, something which is not valid, and therefore portion G of the given graph is not correct. In a single graph, you have understood everything regarding distance. Distance is something, it should be positive always. It can never decrease. And time is also something which is always positive and should never decrease. Note down everything like this, and then we'll see displacement. Note down this much. Write down displacement. Displacement. Write down the statement first. Shortest distance between initial and final points. Shortest distance between initial and final points is called displacement. Shortest distance between initial and final points is called displacement. Write down properties of displacement. Properties of displacement. First one, displacement is a vector quantity. Displacement is a vector quantity. That is, it has magnitude. That is, it has magnitude as well as direction. We'll deal with vectors separately, but as of now, just introduction. And everybody knows a little bit about vectors. And then we'll conduct separate classes for these mathematical tools. As of now, vector is something which has magnitude as well as direction. So, first property is displacement is a vector. That is, it has magnitude as well as direction. What is the direction? Write down that. Direction of displacement, the same property, first property. Direction of displacement is from initial to final point. From initial to the final point. Suppose this is the path. This is path of an object. If you measure its length, it will give you what? Distance. We are interested in what? Displacement. You started from A. A is your initial point. And finally you reach B. B is your final point. Started from A and you reach finally at B. Then what is displacement? Displacement is shortest distance between A and B. Shortest distance between A and B. I hope you can see it. But now look at this part. Displacement is a vector. And vector also has what? Direction. That direction is shown in this form. Look at this arrowhead. I hope you can see the arrowhead. This is the arrowhead. If any time you find that video is blurred or my voice is cracking, then disconnect and reconnect again. And if it persists, then write down the message in the comment box. Maybe there is a problem from my side. Now look here. What is the direction of displacement? Displacement, its direction is from initial to final. which is shown with the help of this arrow. This blue line is called what? Displacement. This black, which is the path length, it gives you what? Distance. Draw this figure and note down everything in this form. And if possible, always use different colors the way I am trying to use, so that you can easily distinguish between different quantities. Put on this much. Write down the second property. Second property is displacement. Displacement can be positive as well as negative. Displacement can be positive as well as negative. Now, what is the meaning of positive and negative? Let's focus on this part. With the second point, continue, write down the additional line to the second point. Positive and negative signs for a vector provide information of direction. Positive and negative signs for a vector provide information of direction. That is if I wanted to use this graph and for displacement, and therefore I wanted to keep it. I hope you can see. Look here. The second point, what I am saying is this. I hope you know that this is east and this direction is west. This is east-west line. This is east and this is what? West. If somebody says that east is plus, then they will say that west is what? Minus. If east is plus, then west becomes minus. So, what do you mean by plus and minus? Plus and minus for a vector, they provide what? Sense of direction. Plus east. If I say that, somebody somebody has given me this information that east is plus and west is minus, and they provide me this information that displacement is plus 5. Well, this is a brief introduction of vectors. You will get it separately as I am telling you in detail. As of now, if somebody says displacement is plus 5 meters, that will be called a coded language. The person who knows that displacement is a vector will immediately tell us that this plus 5 meter is nothing but 5 meters east. So, with vectors, remember, plus and minus, they are used for what? Directions. Something like this. Now, go down this information, draw this figure and this, and I don't know whether I completed my sentence or not. If anybody could tell me what was the last line I was telling you, and switch on your mic. What was the last point which we wrote? Can anyone tell me?
Positive and negative signs for a vector provide information on direction.
That is if east represents positive, that is if east represents positive, then west is negative. East is positive, then west is negative. And now note down this figure, and also write down this. Displacement of plus 5, it means 5 meters east. Now it's not about east and west. If somebody says that north is plus, then for him south will be what? Minus. Similarly, if somebody says that plus represents up, then for him minus will be what? Down. This is, you will define in that particular part what plus and minus they are basically being used for. In this example which I gave you, I told you that east is plus. In some other example, they can represent some other directional senses, and therefore also write down this. Similarly, if plus is used for north, then minus is for south. Or if plus is used for up, then minus is for down. If plus is used for up, then minus is used for down. And they will beforehand define these things, that for them, what is the meaning of plus? Is it north? Is it east? Or is it up? So I hope that when we say that displacement is positive, what the positive sign, or when I say displacement is negative, then the negative sign tells us. With distance, we do not use these signs because you know that distance, it doesn't provide us sense of direction. That was your second point. Now, write down the third point. you remember properties of distance, third point was that distance is something which can never decrease. Now let's see, what do you think? What do you think regarding displacement? Can it increase or decrease, or it only increases? What do you think? If you think that it can increase as well as decrease, then write down both. If you think that it can only increase, then write down increase in the comment box. What is your opinion? Good. A displacement is basically what? Shortest distance between initial and final points. If you start coming back for the starting point, definitely your shortest distance is decreasing. Write down the third point. Displacement can increase as well as decrease. Displacement can increase as well as decrease as it represents shortest distance between initial and final points. As it represents shortest distance between initial and final points. If this is the starting point and an object starts moving away from it, we'll say that displacement is increasing. If it stops, then we say that displacement is not increasing, it has become constant. If the object goes back towards the starting point, then you can see that shortest distance is decreasing, and therefore we say that displacement is something which can increase as well as decrease. Next point. Last 2 points are same for distance and displacement. Unit of displacement is meters. Unit of displacement is meters, because it is basically what? Shortest distance. And the last point, dimensional formula. Again, I briefed you regarding dimensional formula a little bit in the last class, and in detail we'll see it later on. Capital M is not meter, capital M for mass. In length there is no mass. Power is 0. Length, power is 1. There is no time, 0. This is called dimensional formula of displacement. There is no mass, term of length is present once in the numerator, there is no time involved, T for time. Remember, M is not meter, capital M is for mass. So unit is what? Small m, that is meters. Put on these last 2 points. Now suppose I gave you this graph at same time. You do one thing, draw the same graph again, but this time round Replace your small d with capital D. Capital D for displacement. And this is your time axis. These are the different portions. Now tell me which portions are correct in this graph. Draw the graph, write down the answer in the comment box. Go through all the properties I gave you for displacement. Which portions of this graph you think are correct? Take your time, draw the graph, read the properties of displacement. If any portion of the graph doesn't satisfy that part, any of the property, then it will not be possible. Look here. First part. First part says that your displacement is negative. Can you see the board clearly or is it coming blurred? I think it's clear now. Look at this first part, A. In the first part, capital D, that is displacement. Displacement is negative. There is no issue with displacement being negative, it can be. The problem is that time is also negative. The time cannot be negative. Because of this, we'll say that this is the reason graph A is not possible. Look at B. B says your time is positive on this side, on this side. This is origin. On the right side of origin, time is positive. Below the origin, your displacement is negative. No issue. Time should be positive. Displacement should be negative. Nothing is wrong. Both are correct. And therefore, this portion is not allowed, but this portion is valid. C, everything is correct with C. It is also correct with distance. Things are increasing. Everything is positive. Nothing is wrong. Similarly, this D part is also correct. everything is positive, displacement is constant, nothing is wrong. Part E, time is positive, displacement is positive, displacement is decreasing. And all these things are valid, nothing is wrong. And therefore, portion E is also valid. Nothing is wrong with this. F, again everything is correct. Things are positive and they are also increasing. Nothing is wrong with F. And the last part, again, everything is correct except time. Time is decreasing. Whatever you do, you cannot decrease time, and therefore this portion G is not correct. The correct answer is what? B is valid, C is valid, D is valid, E is valid, F is valid. B, C, D, E, F, that is the correct answer. Note down everything in this form. This G portion, what G says is this. Look at this part G over here. If I draw the last portion only, this. And what this portion says, this is suppose is 4 seconds. This is 4 seconds. This is 3 seconds. This is 4. This is 3. But remember, your graph is running in this direction. This arrow is the arrow is just to tell you that we are moving in this form. This, and this. This arrow is not for vector or anything. This arrow is telling you the way you are using your graph. What does it tell you? It tells you that when time is 4 seconds, your distance is positive. When time is 3 seconds, your distance is positive. If somebody looks at this in this form, only in this form, if I do not use this arrow, then everything is correct. If I do not let you know about the time part, then everything is correct. The problem is that we have been given this, that the graph says after 4 seconds, comes what? 3 seconds. There is no way you can decrease the time, and therefore this graph is not possible. Now, let's see some elementary questions regarding displacement. Write down a question. An object is moving in a circular path. An object is moving in a circular path of radius r. An object is moving in a circular path of radius r. This radius is r. This is the starting point, initial point. Find out magnitude of displacement. Find out magnitude of its displacement. Magnitude of its displacement. I'm not interested in direction as of now. Magnitude of displacement if you need to answer magnitude of displacement for all these parts. If it travels 60 degrees, if it covers an angle of what? 60, 90, 180, and finally 360. The question is, it started from this point, that's the initial point. When angle is what? 60. 60 means what? This is the starting point. If it reaches this position, what is the angle? 60. That's the first part. What is the angle? 90, 180, and 360. Let's see what do you know about these basic things, and then I will help you. Write down your answers, write down your answer in the comment box in the same sequence. Displacement in terms of r for all these angles. Hold down the question and write down your answer in the comment box. Take your time. It's not difficult. Everybody can answer it. Just pay attention to the setup I told you. 60, 90, 180, 360. If you're not able to solve all the parts, then whichever part you solve, write the answer for that. Mention the angle and give me the magnitude for that particular part. Look, let's handle third and fourth first because they are very easy. Third says you started from this point and you arrived at this point. This is initial point. This is final point. You can also draw the same figure for every question. This is the initial point. This is final. This is your path length. Path length. We are not interested in path length. We are interested in what? Displacement. What is displacement? Shortest distance between initial and final points. And I told you I need magnitude of displacement. Magnitude means value, the number. If you have a circle of radius r, I don't think I need to tell you that this much is 2r. Third part, done. Fourth part. What is fourth part? 360. Well, in case you do not know what 360 is, this is 90. This is 180. This is 270. This is 360. Again, it's a table of 9. 9 ones are 9. 2s are 18. 3s 27. 4 36. So 360 means your path will be like this. You started from this point and you are back at the same point. You started from this point, you're moving like this, moving like this, moving this, and finally you're saying that initial and final, they both are same. If you reach back to the same point you started from, you know that your displacement will be 0. So I hope that third and fourth, they are very elementary. 2R and D, 0. So the second one is also not that difficult. Look at the second one. In the second one, you started from this position and you arrive at this position. And you can remove the rest of the circle. Let me draw it a bit larger. The second part is this. The second part, You started from this position, initial, and you arrive at this. I hope you can see the figure. This is initial, this is final, this is your path. We are not interested in path, we are interested in displacement. This is the displacement. Make a habit to draw this arrowhead. It gives you what direction of displacement, although we do not need it, but for the next class, we'll also discuss this thing. From initial towards final, length of this. Now, this is something which is very elementary. This is our from Pythagoras. You know that this length is coming root over r square plus r square, which is r root 2. Go down this first, and then I will solve the first part. So those of you who have not answered the first part, I am drawing a figure for you. Draw that figure and investigate displacement for the first part. And I hope you can do that. Just give it a try. I'll give you 1 minute more, and I'm giving you also the hint. You started from this position. This is your I for initial. And you arrive at this position, F for final. This is the path. Object is moving like this. It is found that this angle is 60 degrees. This is R. This is R. The question is find out displacement. What is displacement? Shortest distance between initial and final points. And as I told you, don't forget to put this arrowhead. You need to find length of this blue arrow. Length means magnitude. I'm giving you 1 minute's time. I've drawn the figure of the first part. I hope you can answer this thing. Those of you who have not answered the first part, write down the answer for the first one. Draw the figure and produce an answer. Good. Everybody can see an equilateral triangle, I suppose. You all can see we have an equilateral triangle, and therefore in just one line we can say that the angle is what? 60. This is R, this is R. Your displacement is also R. See, this is R. This is also R. Now, R and R, let's use a simple argument. This is R, this is R. Two arms are equal. First of all, two arms are equal. That makes it an isosceles triangle. If it is an isosceles triangle, then this angle and this angle, they should be same. You have a triangle. And in the triangle, you have been told that this arm and this arm, they are equal. That makes it an isosceles triangle, which means these base angles, they are also equal. But this is 60 and sum of all three is what? 180. But they are equal. Only one option is left. 60, 60. Which makes it what? An equilateral triangle. So this is our, first it was what? Initially it was only an isosceles triangle. And then you found that it is also an equilateral, which means this line, length of blue line is what? R. This is for school examination. Now let's see if I increase the level slightly. Let's see how many of you will answer the next part. In the fifth part of the same question, I've been told that angle is 120. Let's see how many of you can produce displacement for 120. Draw the figure exactly the way I am drawing that. Show the initial point, show the final point, show the path, then draw a displacement line. Don't forget to use arrowhead. We will need this arrowhead when we discuss direction. Find me the displacement for 120 degrees. If angle covered by the object is 120, then what do you think is the displacement? I will draw the path and then you try the question. Draw a circle. This is your initial point. This is 90 and therefore you will reach somewhere here. Final. We need to find this length. Let's call it D, displacement. And we have been given that this angle is 120. This is R. This is R. So what an elementary question this is. You have a triangle. You know two arms. You have the idea of the angle. And you need to calculate the third arm. That's what the question is. I hope you can answer it. Let me draw this figure over here with this much change in orientation, so that you can see what is that we are interested in. So I have basically been given a triangle like this. I've been given a triangle like this. Remember, this is the blue one. The blue arm is here. Remember this. What I did, I am drawing this triangle in this form. I hope you understand what we are doing. This. That's the blue one. We need to measure it. Now, what is this length? R. What is this length? R. What is the total angle? 120. I hope you can see it, that if I draw a perpendicular bisector, it is an isosceles triangle, and therefore if I draw a perpendicular bisector, I will get d by 2 and d by 2. This is d by 2, this is d by 2. I have simply dropped a perpendicular from this point over the base. And we also know that this angle is now 60, this angle is now 60. This much knowledge is required. Now you've got 30 seconds time. Those of you who could not solve it, I think after this point, you can calculate D. Put on this, and if you can produce a correct answer, then give it a try. I think you can do it now. Only a few have answered this thing. Look at only any one part of this triangle, right angle triangle. The right angle triangle which you see is in this form. This is R, this is D by 2, this is 60. R 60 D by 2. Now, in this figure, what is sine of 60? You just need to find this. In this figure, what is sine of 60? Is it d by 2 upon r or this upon r? And I hope you know that when you talk about sine, you are interested in what? Perpendicular. What is perpendicular? If this is the angle, you know that this is your perpendicular, this is your base. That's your hypotenuse. Many times people think that this is base. No. The arm, which is opposite to the angle, is what? Perpendicular. What is sine? Perpendicular d by 2 upon your hypotenuse, which is r. Sine 60 is this. And you know what sine 60 is. Sine 60 is, let's write down this way. This is now d by 2 is r times sine of 60. D by 2 times r of sine 60, which gives us d as 2r sine 60. Multiply, you get this 2r. What is sine 60? Sine 60 is root 3 by 2. Root 3 by 2. 2 and 2 cancelled. Your answer is coming what? Root 3r. You don't need d by 2. Aim is to find what? Displacement. What is displacement? This is displacement. What is the answer? Root 3r. Go down like this. And if you have understood this much, then write down yes. If you are confused, write down no in the comment box. If you could not solve it, but you have understood the whole calculation, then write down yes. And if you think that you are still confused, then don't hesitate, write down no in the comment box. Now, let's see the way they ask this question in competitive examinations. Same type, and that will also help us in understanding the growth which takes place from school to competitive examination. Write down the question. The way same thing will be asked in competitive examination, and I'm giving you this question so that any confusion whatsoever, if it is left, that will be clear in the next part. Let's not waste time. We have been given that this is theta. I hope you know the symbol. This is theta. If angle covered is theta, then we need to find displacement covered by the object in terms of its radius r and angle covered theta. Good. Write down the question. Find out displacement. Find out displacement in terms of radius r, in terms of find out displacement in terms of radius r and angle covered by the object theta. An angle covered by the object theta. What I'm saying is the first question which I gave you, in that theta was 60. In the second case, theta was 90. In the third case, theta was 180, and so on. So if they ask you a general question, instead of 60, 90, 180, all this, if I ask you, get me displacement in terms of theta, what is theta? Theta is the angle covered. It can be anything now. Then what is your displacement? Write down the answer in the comment box. You've got 1 minute's time. Let's see how many of you can find it. Now everything is on the board. Take help from the figure which I have drawn here. Now let me give you the hint. Small one. Question is basically this. Remove this 120, draw the same figure and simply write theta. Once you write theta, now I hope you can proceed further exactly in the same way. Your final answer should be in terms of theta and r. Draw a figure like this. You started from this. That's how you moved. You arrived at this final position. That's your displacement. And you need to find length of this line. I'll tell you once others also try. Let them try first. And then I'll inform you whether your answer is correct or not. Second hint. Draw the same triangle in this form and your 60, 60, 60 and 60, they are no longer 60. You can replace them with theta by 2. If I draw a perpendicular bisector, which in this figure is this, and theta by 2, theta by 2. Now, this thing is this. we are basically repeating same thing. What you need to replace your 60. You need to replace your 60 with what? Theta by 2 now. This angle is theta by 2. What is this? Theta by 2. What is this? Theta by 2. Drawing this much. Now what is the last step? Last step, instead of writing 60, write what? Theta by 2. This is your theta by 2. What is sine of theta by 2? What is sine of theta by 2? D by 2 divided by R. What is this? This is D by 2 is R multiplied by sine of theta by 2. Cross multiply. Which is what? Your D is coming 2 multiplied by R sine of theta by 2. Write down this and also write down result. Throughout the year, we will develop result type of things for competitive examinations. We know how to handle this question. We know. But if they ask the same question in any competitive examinations or in your school examination as an objective one, then you should remember this result. It will save you a lot of time if you remember these things. Or you will save time, I will tell you that. But this type of thing will be called from now on a result. And whenever I give you something like this, you will remember these things. In the same form, D is coming 2R sine theta by 2. Write down the result. And how does it help us? We'll see that. First, note down this. Divyansh, your answer was correct. Now, if there is anyone who could reach the same answer but somehow could not write it, be honest. What I'm asking, at times it becomes difficult for you to write theta and all. What I wanted you to write theta as theta only, theta. So if somebody could arrive at the same answer but somehow could not write it, be honest, then write down yes in the comment box. No one, other than one person who has answered it correctly. Good. But now, does everyone understand this question now? If I ask you, how many of you understand it? If you understand the final answer result, then write down yes in the comment box. If you are confused, simply write down no. I will explain that part again. There is no issue because this is a very elementary example. Now, why did I tell you that this thing is a result in competitive examinations like JEE and NEET? If they ask you this question, they may ask you this question in terms of theta, or they can ask you question in terms of 120 and all. Then you will remember what is the answer? 2r sine theta by 2. Now, look at the advantage. Look at the advantage of the whole thing. What was the first part? First part was 60 degrees. That means theta was what? 60. If the question comes in neat or J, you will not draw these figures and all. That is wasted of time. You will simply go for 2r sine theta by 2. Look, 60 by 2. What is this? 2r sine 30. And I hope each and everyone in the class knows what sine 30 is. What is sine 30? 1 by 2. 2 and 2 cancelled. The answer is what? R. When we were 60, we got an equilateral triangle, and if you remember, answer was what? R. You're saving a lot of time. You don't have to draw these things by remembering the result in 2r sine theta by 2. If they ask this question in school in objective form or in any competitive examinations, these results will help you. You can answer the whole thing in just 10 seconds. Now for theta equals to 90, use the result, and once you get the same answer, write down yes in the comment box. We have already done for 90. What I want from you is use the result for theta equals to 90. If you get the same result, then write down yes in the comment box. Once you get it, write down yes in the comment box. Just to let you know the advantage of the whole thing. Look here. If theta is 90, then this is 2r sine 90 by 2. Remember, this is theta by 2, 90 by 2. What is that? 2r sine of 45 degrees. 90 upon 2. What is sine 45? 1 by root 2. This is 2, this is root 2. Your answer is coming what? Root 2r. You're saving a lot of time if you remember these results. Hopefully you understand this much. Next class will be the important class. We will discuss vectors so that we can find directions of these displacements and all. Note down this much and then you can leave. Thank you very much.
Thank you, sir.
Thank you, sir.